Hit record. And you know about being able to toggle the control panel on and off?
Yeah.
Okay. Now, we're going to start at the first one?
Yes.
Okay. I can use properties of equilateral, isosceles, and mid-segments to solve problems. Okay. Solve for x. So the fact that that is a mid-segment means what relative to its length
It's
relative
halfway.
to 16?
It's halfway in between 16, so it'd be 8.
Okay, so therefore 2x is equal to 8, right? In other words, that section right there is half of 16, which is 8. So 2x equals 8, x equals 4.
Simple.
Okay. Number 2, find the value of xy, that line, and yz, that bottom line. And the way we're going to do that is, what kind of triangle is this, and why?
It is, I don't know.
Hold on a second, I need to shut my door. Okay, go ahead. I'm sorry, what would you say, Bradley?
I don't know what type of triangle it is.
They don't give us a lot of information about it, but they do tell us that that angle is equal to that angle. What kind of triangle does that make it? Go back to the directions. We got 3 kinds of triangles. Which one?
Equilateral.
Equilateral is all 3 sides are equal and all 3 angles are equal.
And then isosceles.
Correct. Isosceles means 2 sides only are equal. Okay? And it's the sides opposite those 2 equal angles. In other words, that side is equal to that side. Now, most of the time, you define an isosceles triangle as having 2 sides that are equal. And then you have to follow it up with saying their opposite angles are equal also. But certainly if you find a triangle that tells you it has 2 angles that are equal, that means it's isosceles, for sure. So what equation can I write to solve for x if I know that this side is equal to this side?
4x, is that 4x plus 1 equals 4x plus 4?
Equals x plus 4, is that what you said?
Yeah.
Okay, what's the solution here?
So you would subtract 1x.
Give me I tell you what, just give me the next line. I don't care how you do it, just verbalize to me the next line.
3x plus 3
equals 3?
Yeah.
That's how you would verbalize it. You need the equal sign there. And the next line?
X equals 1.
Okay, and now it wants to know the value of line segment XY, so what is it?
5.
And the value of the bottom one? Y is
5.
Also 5. And in fact, to get the value of the bottom one, I really didn't need to plug it in. I just needed to know that it was isosceles, so it had to also be 5.
Because the 2 angles are the same?
Yeah, exactly. Whenever you have 2 angles the same, it means their opposite sides are the same.
Okay.
In fact, let's just talk about a concept here. If I have 50, 60, and 70 angles, degree angles, those add to 180. And there's a rule in geometry that says the longest side of the triangle has to be opposite the biggest angle. And the shortest side of the triangle is always opposite the smallest angle. So if I had to rank the lengths of x, y, and z, I would know x is the biggest one, bigger than y, which is bigger than z. So z is the smallest, x is the biggest. Good thing to know about triangles. And
So it's just
if you have two
the
angles
biggest.
that are equal, then their opposite sides are equal also.
Okay. Yeah.
So let me scroll down here and take a snapshot of this. What kind of triangle is this?
Isosceles.
So give me an equation that I can write regarding something that has x in it.
For x plus 7 equals 56.
Correct. Remember, it's the opposite sides or the opposite angles that are equal. It's not this vertex angle. And do you have any questions as to how to find the side opposite an angle? In other words, if I want to know the side opposite that 56-degree angle, I just extend those two rays all the way out, and the line that connects them, that's the side that's opposite, always.
So it would be 8 would be the opposite of
Well,
50.
8 is the opposite side to 56, and
Yeah.
this 8 is the opposite side to this angle. And that's
Okay.
what allowed you to say that x plus 7 was equal to 56. So x is equal to 49. So that's the answer.
One second, my brother walked in.
Okay. Good to go, or you need me to wait a little bit?
Wait, will you say what you just said again? My brother walked in.
Okay. X is what you're solving for.
Yeah.
It's 49. It's not 56. They didn't ask for what the measurement of that angle was. They asked for what x was. So we set x plus 7 equal to 56, therefore x is equal to 49.
How would it be? Wait, would you just?
What I said at the very end was they weren't asking for this angle.
Yeah.
They were asking for x. That angle is 56, which makes x 49.
Oh, okay. Yeah.
Any questions on that problem
No.
before we move to the next? What kind of triangle is this?
A equilateral or
Correct.
isosceles?
Well, put it this way. Whenever you have an isosceles triangle where the two angles are 60 degrees, then the third one is also 60 because they have to add to 180.
180.
This is a very special isosceles triangle. It's an equilateral triangle. So all three angles are equal and all three sides are equal. So they want to solve for a bunch of stuff. First, x and y. So find me an equation that lets me solve for x.
8x minus 4 equals 20.
Solve that.
Let's add 4 to 20,
Okay, next
and
line.
it's 24. And then you divide 24 by 8, and it would be 3.
Okay, so you solve for x. Now find me an equation that relates y to some number.
8y plus 4 equals 60.
Solve that.
So 60 minus 4 is 56. And that would be 6.
7.
7.
7 times 8 is 56. Okay, so now we've solved for x and y, which they wanted. Now BC, they want that length.
So you just plug 3 into 8x minus 4.
Okay, what do you get?
So 8 times 3 is 24. So it'd be 20.
Ha, we didn't really need to go to all that work. You're right, it's 20. But guess what? We knew it was 20 because we knew it was an equilateral triangle.
Equilateral.
Yeah.
Okay.
So AC is also 20. In other words,
So,
it's useful to remember that so that you don't waste time doing math that you don't need to do or that you
so,
make a mistake on. In other words, it's always possible to make a mistake when you're plugging in.
so if it's an equilateral, you don't have to do any of that because all the sides are equal.
All three sides are equal. All three angles are equal.
Oh, okay.
That's a very, very special triangle. I mean, you don't run across it very often. All right. All right. Whenever they give you one of these XY coordinate system questions,
Yeah.
probably the best thing to do is let's go ahead and approximate a graph. Okay, you don't need to put a grid on this XY system here. Because all you need to know is approximately. Where is 2 comma 7? Well, if I make that 2, then 7 would be about there. Okay, so that's 2 comma 7, and that is point P. Q is at 2 comma minus 3. Well, that's going to be about there. And again, don't waste time putting a grid on it because this is ultimately an algebra problem, not a geometry problem. It's just that we're going to be able to use our picture to come up with the algebra of it.
Okay.
Now, that is point Q. Which could be the coordinates of R if PQR is an isosceles triangle?
It could be,
So first of all, let's go ahead and draw a line between there, because clearly that's one part of the triangle, right?
yeah.
They're saying there is some R out here that if I make a triangle, it'll be isosceles. Well, clearly if R is there, that might be isosceles, because it could be this length would be the same as that length. So what we really have to do is just kind of try these points rather than do much in the way of equations, although we'll get to that with one of them, I guarantee it. Let's plot 12 comma minus 3. Okay, well 12's way out here. Minus 3, we know where that is. Could that be an isosceles triangle?
Yeah.
What would it require for that to be an isosceles triangle?
Wouldn't two angles or sides be the same?
Or two sides. We don't know much about angles here.
So two sides. So
We do know the length of this side. What is that? What's that length?
of which one?
Of PQ.
It is 10.
Okay. So if the length of this dotted line was also 10,
Then it'd be an isosceles.
then it would be an isosceles triangle. And it is. The distance between 2 and 12 is 10. So that is definitely an answer. Now we got lucky. Whenever you're trying points, you don't usually get it on the first try, but sometimes you do. Now let's just take a look at this other point. -6 minus 9. Well, -6 is about there, -9 is there. Question is, clearly that's the only side that could be 10, and you'd have to do a lot of complicated math to figure out whether that distance, you'd have to use the distance formula between 2 points. Only one of these answers is correct. Am I correct?
Yeah.
Well, the beauty of discovering it with A is that it was relatively easy to figure out. Didn't have to use the distance formula. And it kept us from having to do all of the hard math if they would have made that answer D instead of A. Because if they had made it D, we'd have had to check all these 3 points. And some of them are going to be really clearly difficult to check. You're going to have to use a distance formula between 2 points that aren't horizontal or vertical. In other words, figuring out to see whether that was 10 or not, that would have been hard to do. We won't spend, what's that?
Wouldn't C be out of the question though, because it's a negative 117?
Yes. In other words, it's a negative 117 and 2. So it would be somewhere way out there, and there's no way for that right triangle to be an isosceles triangle. Would be a right triangle, but it could not be isosceles. Sometimes right triangles can be isosceles. In other words, the very first answer where it was 12 minus 3, that is a right triangle. It just happens to be an isosceles right triangle, where it's very easy to measure both sides because they're a horizontal and a vertical line. All right, I say we go on to the others. Not that we couldn't learn something about things if we checked B, C, and D, but we're going to spend all of our time doing distance formulas. That's not really what they want here. At least I haven't seen a question about a distance formula yet, although theoretically I suppose the last question was, although not really. But all right, here let's look at what they're talking about. They're talking about medians, altitudes, and perpendicular bisectors. So first of all, let's talk about what each one of those are. Let's talk about what a median is. And this triangle isn't the best triangle to use because that's an equilateral triangle. Okay, let's use a triangle that's not an equilateral triangle. Something like that. Okay?
Okay.
A median is you start from each vertex and you go to the middle of the opposite side. So that's a median. Or that is a median. And finally, that is a median. Turns out that if you draw 3 medians on any triangle, they have a point of coincidence where all 3 lines cross at the same point. And it's worth knowing where that point is a lot of times. Okay?
Okay.
Now let's talk about altitudes. I'll draw that up here. If I have a triangle like this, an altitude is where you start from one vertex and you draw a line that is perpendicular to the other side. Like that. It's not a median. I didn't go to the middle of the other side. I just drew my line however I had to make sure that's a right angle. And if I do it for that vertex, it's going to look like that. And if I do it for this vertex, it's going to look like that. Notice that all of those are right angles, but there's also a point of coincidence where all three lines meet. Perpendicular bisectors are particularly useful with an isosceles triangle. It's where you drop an altitude basically and it becomes a bisector. In other words, it bisects that angle and it also is perpendicular to the opposite side. One second. Make sure I'm not making a mistake here. Get my geometry book out. This is one of those geometry things where it never gets brought up again.
Yeah.
Believe it or not, you're not going to be tested on this particular thing in the SAT test or the ACT test.
Why do we learn it if
it's just going a little bit above and beyond for geometry? I don't know, but it's one of the things that I don't get all that often. I'm trying to find. It's right here. Hold on a second. There are usefulnesses of it. So it's not like it doesn't have a purpose, but that's not where I'm not finding it. Hold on a second. I hate it when I have to waste your time doing this. But concurrency, point of concurrency, 272. Oh, that's close. All right, I was wrong. The perpendicular bisectors. Let's talk about that one again. These first two are correct. That's a median, and that's an altitude. Okay. What I drew over here was an altitude for an isosceles triangle, which is kind of a median and an altitude combined. But
isn't that what
a perpendicular bisector is the following. A perpendicular bisector is where you start from the middle of each side and you draw a perpendicular line. Okay, now I'm going to start from the middle of that side and I draw a perpendicular line. And I'm going to start from the middle of that side and I draw a perpendicular line. That is a perpendicular bisector. It's not bisecting the angle, it's bisecting the side. And it's perpendicular from that point. And that is different than a median, and it's also different than an altitude. Now, why is this important? Because when you have a perpendicular bisector like this, it means the distance to each vertex is the same, which means I can put a circle around that because I know that that is the center of the circle. In other words, let me do it in a different color here. This is the important thing about these questions. That distance is the same as that distance, which is the same as that distance, whenever you use a perpendicular bisector. Now this one doesn't talk about an angle bisector, but that has another property. We'll get back to that if they bring it up. But if we don't, we'll just talk about these three. Okay, they're saying NP is a median, find PO. If MP is a median, what does it mean about NP and PO?
It's the middle.
So they're equal.
Yeah.
So 3x minus 4 has to be equal to 5x minus 10. Find the length of PO. Keep going with this equation.
Okay, so you would, here, can you scoot the problem over a little bit? It's like off the screen.
Yeah, yeah, I can here. Let's do it down here. I actually can't scoot it over, but this works just as good. Okay.
So it is 2x
On which side?
on the left.
Now,
2x.
if I'm putting my variables on the left, it's going to be minus 2x. If I'm putting my variables on the right, it's going to be positive 2x. Which side do I want to put them on?
Positive side.
The right.
So right.
So I'm going to subtract 3x from both sides, and that's going to leave a 2x over there.
And then
I'm going to move my numbers to the left. So what happens when I move my 10 over?
so you add 10, so it'd be a 6. So 6
To
equals.
me, that's the best way to do algebra, is move your variables to the side that's going to give you a positive coefficient. Now, I could have gone the other way, in which case my answer would have been minus 2x equals minus 6. But I would have had to deal with a lot more negative numbers, and negative numbers always induces mistakes. Okay, so what's the answer here? What is PO?
It would be 5.
Correct. Okay, hold on a second. Let me scroll up. Oh, I forgot I can't scroll up anymore. That's okay. Just erased everything. So they're saying NQ is the altitude, and that angle, or excuse me, that NQM excuse me, NQ is the altitude, and little m, which I presume means angle M, is less than MQM, which is a right angle. So they're saying this angle right there is less than that right angle. Well, that's always the case. When you have a right angle in a triangle, it's always the biggest angle. I'm not quite sure what that says. Oh, it says it's less than. That's confusing. I'm not quite sure what they mean by that.
Don't either.
Let me look at this again here. Now, this is puzzling. Usually I don't see geometry problems where I can't figure out what they're talking about. NQ, that's this, is the altitude because it goes from the vertex perpendicularly to the other side, okay? And this part here is what I don't understand. And they want us to solve for x.
Wouldn't it be just
Which is
6x
length? We just solved for x in the previous problem. No, we didn't. Well, hold on. This is very confusing. We did solve for x in the previous problem. It was x equals 3. So nothing's changed here. So our x must be 18 minus 6. No. We know. Okay, so 12 equals NQM. What can they possibly mean with NQM? That's an angle. But they don't put the little angle sign in front of it. Don't know what question B wants. Cannot figure it out.
Should I ask her at school tomorrow?
You can certainly do that. Unfortunately, we won't meet again until next Sunday. But yeah, I do not understand. Even if we use median altitude, what could they mean there? Now I know. I apologize. Now I remember how this works. This sign there, that's not a less than or equal sign. That's an angle sign. So it's just that the printer that she's using doesn't have the ability to write the angle sign. So what that means is the measurement of angle in QM equals 6x minus 6. This is a different x. But what do we know the measurement of NQM is? If this is a right angle, what is NQM?
90.
Has to be. That also is a right angle. So that's equal to 90. Now we just solve that equation. 6x equals 96. X equals 16. So that is a different x, which is very bizarre. You wouldn't think they would use a different x in the same drawing to mean different numbers, but they did. Plus, that thing really meant that. That's why I couldn't understand it. I kept looking at it as a less than sign. All right, let's see. We must have another page here, I presume.
Yeah, I sent it to you.
I heard. Which one of these are we looking at?
The second one I sent. So
bottom one here.
let me look.
Top one doesn't look like it has a lot on it, but oh, it must be the top of the page.
Yeah, it's the I think it's the other one because.
Here, I'll take a quick peek at it. Well, let me download it. Doesn't like opening it unless I download it first. All right, this is where we want to start.
Yeah, 9 and 10, because we did 11, 12, and 13 the last two lessons.
Okay. Okay, this question has to do with what I mentioned earlier.
Oh, okay.
Lengths of the sides of a triangle always match the size of their angles. So, what's the biggest angle? Well, first of all, let's draw a picture just to make sure we know how to label this triangle. Okay? I'm going to call that AB, because that's 15. And then AC is 6. And then BC would be 8. Close enough. Okay? So there's our picture. Now tell me angles. Order the angles from least to greatest.
So, BAC.
What's the least angle?
B.
Okay, that's not BAC, that's ABC. But we can get away with using single letter notations. So I'm just going to call it the measurement of angle B is the least than, what's the next smallest angle?
A.
So the measurement of angle A, and finally
C.
And whether you read that from left to right or right to left, it's true. In other words, B is less than A, which is less than C. And I guess this is proper notation. You need that little m there. Now, you could call that, let's just make sure you understand this, that is angle ABC. The vertex is always the middle letter. This is angle CAB. And this is angle ACB. You get it? You can go in whatever order you want, but the middle letter has to be where the vertex of the angle is.
Okay.
Okay. List the sides in order from smallest to largest on 10.
So when you add 55 plus 62 and subtract 180 from that?
That at least gives us measurement B, which we need. So what is that?
Hold on, let me get my calculator. 55 plus 62 equals 117, 118 minus 117 is 63.
Now, which is the largest side? This is the smallest. The smallest side, excuse me.
The smallest side would be AB.
Correct. So AB
And then
less than the next smallest side.
CB.
Which is less than the largest side, which is AC. On sides, you have to use at least 2 letters. Okay, now let's see. Where do we want to go next?
The next page.
Okay. In other words, we've done all the ones at the bottom of that page. Okay.
Yeah.
So the next page being this one, I guess I can work with it in this format. And we're starting with the top.
Yeah, or 20. I think it's.
I think I'm missing a.
Yeah, it starts at 20.
Starts at 20? Okay. We could draw these 2 triangles and figure out which angles are congruent. And there is something to be learned by that. In other words, when you draw a triangle and you say it's congruent, let's just refresh ourselves on 19.
Okay.
Which angles are equal?
Just A.
No.
A and A.
EFI is one triangle and HGI is another triangle. Just by
Wouldn't
the names alone, you can tell which angles are the same.
so E and H,
Correct. F and G, I.
F and E, it'd be
Well,
G and H.
F and G are also the same.
Yeah.
And I and I. Okay, so we don't need to do that one. Question 20, I can only presume is referring to this graph over here.
Oh yeah, I think so.
Okay. All right. Let's talk about congruency. There's 3 or 4 tests for congruency. There's congruency basically means the same, only they don't have to be oriented the same. If you find all 3 sides of one triangle are the same as all 3 sides of another, that's congruent. If you find side and in-between angle and another side, that's congruent. If you find an angle, a side in between the 2 angles, that's congruent. And this also is congruent, but it has to be the correct side. In other words, it's not just any 2 angles and any side. Those 4 are the tests for congruency. So this question says, what value of x makes these 2 triangles congruent? Well, we know we have one side that's the same, right? CR equals RB. What other side is the same?
CA equals BA.
Not yet. What other side? We got 2 triangles here. I'm going to label them. That's triangle 1, that's triangle 2. I know that CR equals RB.
So
What other side do we know is equal?
AR.
AR equals itself. And AR happens to be part of both triangles. So that is a second side that's equal. So is all I need for these 2 triangles to be congruent is if AC is equal to AB. So I'm going to write that as an equation. If 4x plus 8 is equal to 7x minus 4, then we will have 2 congruent triangles. Again, which side are you going to put the variables?
You're gonna put 3x on the right.
Which side are you going to put the numbers?
The left. So it'd be 12.
Which makes x equal 4. That's the only value of x that will make those 2 triangles congruent.
So x equals 4.
Now, what does Cpctc stand for?
It's congruent, perpendicular,
It's corresponding
corresponding
parts
are congruent.
Congruent triangles are congruent. So if you told me to begin with that these 2 triangles, 1 and 2, were congruent, then I would be able to tell you, well, 4x plus 8 has to be equal to 7x minus 4, because corresponding parts of congruent triangles are congruent. I also would know that angle C is equal to angle B, and that that angle is equal to that angle, and that this little tiny angle up there must be equal to that little tiny angle down there, because corresponding parts of congruent triangles are congruent. When can you use Cpctc?
if the sides are congruent.
Yeah, with congruent triangles. Use the given information to write and solve a system of linear equations to find the values of x and y. Okay. I can't scroll any on that, can I? Maybe a little bit. Yeah, I can. Well, it never hurts to draw a picture, okay? It isn't always necessary, but it never hurts. And we know we have a 28-degree angle here. So we'll kind of draw the first one like that, STU, and we'll draw the second one similar and label it X, Y, Z. And we know that angle T, I didn't draw it right, but that's okay. Doesn't matter. That's 28 degrees, which means that's 28 degrees. Okay. Now they give the other angles U, Z, and Y in terms of these variables. So we need some equations. Well, they give us Z. That helps. We can do that. Now we know what X is. X is 22. Now we know what all these are. Because corresponding parts, because of Cpctc.
Are congruent. Okay.
Yeah, and that's what that says, is those two triangles are congruent. Okay. Now I still have a problem. U, which I know to be 130. So if I take this equation right there, the measurement of angle U is 130, and that's equal to 4x plus y. And the measurement of angle y, which I know to be 28, is equal to 8x minus 6y. So there is the system of two equations that we came up with. And now we can solve for x and y. In other words, if you have an x and a y and only one equation, you can never solve for it. There's an infinite number of solutions. But as long as you have the same number of equations as you have variables, then you can solve it. What do I need to do? What system am I going to use to solve this system of equations? Am I going to use substitution or elimination?
Substitution.
Actually, elimination always works best when they're in this kind of a standard format. Now, they're not an exact standard format. Let me write them in an exact standard format, where you have the x and the y on the left side and you have the numbers on the right. It just came out. I wrote it in the other way, not thinking, but I could have written it this way just as easily. Now, can you see why you want to use elimination?
Yeah.
Yeah, when you've got the variables on the left are both x and y and in the order that they're properly in, with the x being first, the y next, and the number on the right, well, now this is going to be pretty easy to solve by elimination. What do I have to do first?
Subtract 130 from 28.
No, remember I'm trying to eliminate a variable.
So subtract negative 6y from y.
Well, I can't, the only choices I really have are I can add these two equations or I can subtract them. Neither one gets rid of a variable. But what if I multiply equation 1 by -2, both sides? This is how you do this. Okay? Well, it creates a new equation, doesn't it? And that new equation is now this. You with me?
Yeah.
So now let me cross the original equation out. Remember, you're allowed to multiply either side by the same number always in equations. So this bottom equation is the same thing I started with. But now notice that if I add the two equations, a variable is going to go away. X is going to go away. When I add 8x to a -8x, I get 0x. When I add the y's, I get -8y. And when I add the numbers, I get -232. Now solve for y. Divide both sides by -8. What's that give you? 19? Let's see, 52? No, don't tell me they did that to us. They really gave it to us like that. 5.5. To do that on your calculator. 232 divided by 8.
232.
Mm-hmm.
232 divided by 8. It's 29.
29? Good math. 29. I knew it should be an integer. Okay, so we still haven't totally solved it. What we solved for was x. We only have 1 minute to go, so I'll make this quick. We know that, we solved for y. Y is 29. Okay?
Do we do the same thing?
Well, no, we don't have to go through all that work. Is all we got to do is go back, pick one of these original equations, substitute y. I'm going to do this one. I'm going to substitute 29, our answer for y, and I'm going to solve that equation, which now only has one variable. And what it gives me is 4x equals 101, which means x equals whatever 101 divided by 4 is.
So you just put 29 in, so then you subtracted 29 from 130, which is 101, and then you divided by 4?
You got it. And that's x. Okay. So x equals, I'm just going to leave it as a fraction here. So that's what y is, and that's what x is. And nothing said that they had to be whole numbers. That certainly is not 101 divided by 4.
Okay.
Okay. So, Bradley, I am going to let you go, and I'll talk to you next Sunday. I'm glad I figured out what that... Now, how come on this one they were able to print it? They were... Look at the angle sign they use.
My teacher doesn't really care that much.
Well, on the other page, she didn't use the angle sign. She used the less than or equal. That's what screwed me up. All right. You have a good week. I will talk to you next week.
Thank you.
Bye-bye.